For my project, I selected the equation number A. I determined the formula by using the periodic table and the polyatomics chart. I used the crisscross method as well for mercury 2 chloride in order to determine its formula. All the reactants in the beginning being aqueous let me know that the rest of them that followed suit would also be aqueous, and also there would be a solid at the end. And that pattern that followed suit let me know that it was a double displacement reaction for the equation. Another part that helped me determine the formula by knowing that chloride and iodide are negative anions, and by knowing that aluminum and mercury are positive, so that way it would also help when I was using the crisscross method to determine the formula. Another way I was able to determine the states of the reactants was by knowing which elements were soluble in water, so I could say that they were aqueous, or if they weren't soluble, I was able to determine that the final product on the last part was a solid. Solubility rules let me know that mercury combined with iodide is something which is insoluble, and I was able to use that in my reaction. Able to use that rule to determine that the last product is a solid. Using mercury 2 chloride, I was able to determine an ionic formula by placing the symbol for mercury and then by placing the symbol for chloride. Afterwards, I went on the periodic table to determine what were the charges for each of those elements as I went down the row. I was able to find that mercury had 0 charge and that chlorine had a charge of -1. The 2 in the parentheses after mercury, I was able to use the crisscross method to bring it down afterwards and put it right on the opposite side where the chlorine was, so it became a 2 where the 2 in the parentheses was previously. The reaction is a double displacement reaction, and this helped me determine the formula because I was able to use the formatting for it, which is AB plus CD equals AD plus CB. That formatting helped me use the original equation and be able to place it so that it matches up to that format. I was able to balance the equation by setting up a chart and making sure that each of the elements on the reactant side and the product side were able to match up to each other whenever you would cross it out and you were trying to get them to balance and be equal. And in that way, I was able to add a 2 to the aluminum on both sides and add a 3 to the mercury on both sides so that the equation was equal. I was able to determine the limiting reactant as aluminum iodide. I took the 10 grams of aluminum iodide and multiplied it by its 1 mole, which is aluminum equals 26.98 and iodide equals 126.9, so I multiplied that by 3, add the 2 together to get the number which equals 1 mole. After that, I used 10 divided by 407.68 to get 0.025 moles of aluminum iodide. The next part, I took 10 grams of mercury Cl2 and put it over the amount that equaled 1 mole. Mercury equaled 200.6 and chlorine equaled 35.45. And I was able to multiply that by 2 in order to get the right amount. So I took the 10 grams and divided by 271.44 grams, which was the total amount, and I got 0.037 moles of mercury Cl2. And using the balance equation, I knew the 2 moles of the aluminum iodide would be over the 3 moles of mercury chloride. So I took the 0.037 moles, multiplied that by 2/3, and I was able to get 0.025 moles. And I also did that for the bottom portion where I took the amount of moles and I multiplied that by the balanced equation, but instead of 2/3, it was 3/2, and I was able to 0.037 moles. And since for aluminum iodide at the top, I needed 0.024, I was able to determine that the limiting reactant would be aluminum iodide, considering how there was a limiting amount provided compared to the amount that I actually needed. And for number 4, to find the amount of the solid product produced, I took the 0.025 and I multiplied it by what 1 mole of the mercury iodide equaled, which was 454.4 grams, and when I multiplied the 2, I was able to get 11.36 grams of mercury iodide. Number 5, to calculate the percent yield, I took the amount of moles of the solid product, which was 3 moles, and I multiplied that by the amount of moles of the limiting reactant, which was 0.025, and I was able to get 0.075. I took the 0.075 and I multiplied that by the amount of which was the 1 mole of the mercury iodide, and which was 454. And when I multiplied the two, I got 34.08, which was the theoretical yield. So I took the 15 grams of solid that was actually produced, and I divided that by the theoretical yield of 34.08 grams. And when I divided it, I got a 0.44, and I multiplied that by 100, and I got 44%, which is the percent yield for this equation. And that is all for the part 1 of my project.